reflection and transmission at oblique incidence. Consider we have two regions. This is medium 1, this is medium 2, and this is the interface of these two media. And whenever a wave is incident with some arbitrary incident angle theta I, then it can be reflected with some reflected angle theta R, and it can be transmitted with some arbitrary angle theta T. And this is the z axis, and let's suppose this is x. And this is ki, this is kr, and this is kt, which is the wave propagation direction. Then I have written some mathematical steps. General case where a monochromatic wave incident at an arbitrary angle theta I, then the EI, the incident electric field, we can write down like this. Then BI, which is equal to 1 over V Ki cross EI. And this relation can be obtained. This relation can be obtained because we know about the relation of B and E, which is equal to 1 over V and E. This is the relation between E and B. And Ki is the unit vector in this direction. And if Ki, for example, Ki is in this direction, then EI may not have in this direction because E is the polarization, which is mass perpendicular to Ki. So if this is EI and this is Ki, then by cross multiplication, if this is x is the unit vector and this is y is the unit vector, then x cross y must be equal to z. This is BI. So we can use this relation, and we also consider this as a cross product, and we can obtain BI. So actually we are using this relation, and by considering a unit vector Ki with EI, then we must have BI. Similarly, ER, which is equal to E naught R, and this, and BR must be 1 over V1 because V1 in this, the velocity in medium 1, and this is KR cross ER. And the transmitted electric field is equal to this, and the transmitted magnetic field 1 over V2 because this is a second medium and the velocity must have some different value. So 1 over V2 KT unit vector cross ET. So this is the situation when we have an incident angle theta I, and theta R is the reflected and theta T is the transmitted angle. Now, if omega I, which is equal to omega R, and omega T, which is equal to omega, when these all three frequencies are equal, then by definition omega, which is equal to kV, we know about this relation, omega is equal to kV, then we must have Ki V1, which is equal to Kr V1, which is equal to Kt V2, which is equal to omega. all these must be equal. And by taking V1 from this and multiply by this, then we can also write Ki, which is equal to Kr, which is equal to V2 divided by V1 Kt. So Ki, which is equal to Kr, which is equal to V2 divided by V1. This V2 divided by V1, we can also represent this is in another form, because we know as V is equal to C divided by N. N is equal to C divided by V. This is the refractive index. Then V is equal to C divided by V. And V1, which is equal to C divided by N1, and V2, which is equal to C divided by N2. Then V2 divided by V1, which is equal to C divided by N2 and C divided by N1. Then this C will cancel with this, and this V2 divided by V1, which is equal to N1 divided by N2. Then this relation Ki, which is equal to Kr, which is equal to N1 divided by N2 and Kt. So further, Ei plus Er, Ei and Er, and Bi plus Br must be in medium 1. Ei, Er, Bi and Br, these must be in medium 1 and join with medium 2 to the field Et plus Bt. So this is very simple, because we have Ei, Bi, Er, Br, Et and Bt, and this will join with this z is equal to 0. Then e की power I k I dot r minus omega t plus e की power I k r dot r minus omega t, and this is equal to e की power iota kt minus r minus omega t. So what is here? Here we may have the incident electric and magnetic field amplitudes, because I have written this in this form, and we must have electric field and magnetic field. This is a general case, and here we have electric field and magnetic field. ER and BR fields, amplitudes. And similarly here we must have ET, BT fields, amplitudes. So this is a general case. Now at Z is equal to 0, if we consider this joint Z is equal to 0, we must Ki dot R, which is equal to Kr dot R, which is equal to Kt dot R. These must be equal because we also have omega t, which is equal to omega t, and these terms are also equal. And whenever Ki and R, if we multiply these, because Ki must have three components, Kx, Ky, Kz, and R is also Xi, Yj, Zk, and these have these components, then we must, for example, if I consider here, this is Kix, Kix, and a unit vector x plus Ki y, a unit vector y, and take a dot product of this, because z is equal to 0, so there is no need to write down z, and dot r x plus y, and whenever we multiply, take a dot product of this, then kx, this x dot x, this is 1, and y dot y, which is equal to 1, then we can write, using this concept, we can write down this as x kix plus y ki y. And similarly for this one, x kr x plus y kr y plus, but this is equal to, for this one, x kt of x component plus y and kt of y component. Now if x is equal to 0, if we consider here the x is equal to 0, then if x is equal to 0, we must have this component, y ki y, which is equal to y kr y, which is equal to y kt of y. And here the y, this term must cancel out, and we have only ki y, which is equal to kr r, which is equal to kt, and sorry, this is y, and this is also y. And when if y is equal to 0, then kix, similar procedure we can use, kix, which is equal to krx, which is equal to ktx. Then first law. The first law says that the incidence reflected and transmitted wave vectors form a plane, and this is also plane of incidence. Then this equation, if I consider this as equation 1, then equation 1 implies, this is for the case when a wave is a normally incident. This is, for example, the normal incident is if we have a wave front like this, and this is a normal incidence. So the angle is equal to 0, but if a wave front like this, which makes an angle, some incident angle with this axis, this is the axis which makes some incident angle, then this equation can be written in some arbitrary angle. So this ki must be equal to sine theta I, and this is equal to kr sine theta r, which is equal to kt sine theta t. So we use this equation, and by considering some incident angle, then we have incorporated angle theta I, theta r, and theta t. So this is the first law. The second law it tells us that the angle of incidence is equal to the angle of reflection. So this is the second law. It means that theta I, which is equal to theta r, this incident angle must be equal to this incident angle, and this is known as the second law. And this is also known as the law of reflection. Law of reflection. Finally, we have another law which is known as third law, which is very, very important, and this is known as the Snell's law. where sine theta t, which is equal to sine theta I, and this is equal to n1 divided by n2, and this equation is known as Snell's law, which is very, very important.